I'm gonna record this. So for linear inequalities, we are pretty much still reviewing. Shouldn't feel like anything brand new. It should still feel like a review, okay? So our goal here is to understand basic terminology, solve linear inequalities symbolically, solve linear inequalities graphically and numerically, and solve compound inequalities. So inequality rules. So if we look here, we have y is less than, so this is less than, right? Strictly less than, x minus 3. So when I am less than something, I'm going to have a dashed boundary line. So it doesn't look like it, but it is dashed. And I'm going to shade below the boundary line. Easy enough? Okay. Next, if I have less than or equal to, I'm going to have a solid boundary line. So my boundary line is solid, but I'm still shading below it. Pretty straightforward. Do we all remember this? Hopefully. Next. So next we have greater than. And when I'm greater than, I'm going to have a dashed boundary line. And I am shading above. Here, I am greater than or equal to. So I'm going to have a solid boundary line, and we shade above. Any questions about what we just did, my friends? All right, I'm going to keep going. So we're going to talk about how to solve. When you're solving inequalities, you're still doing the same thing as before. So you are trying to get x by itself. So before you solve, you're going to get x by itself. So step one is to isolate the variable. Okay. So the first thing I want to get rid of is this guy, this -4 in the denominator. How do I get rid of -4 in the denominator? Times both sides by -4. So I'm going to multiply this side and this side by -4. So I'm left with -8x minus 4. And what happens is that when you multiply or divide by a negative, you have to flip signs, inequalities. So because I multiply by -4, this inequality also is going to change. So instead of being less than, it's going to become a greater than. And now I have 2 minus x. I'm going to continue to isolate the variable. So I need to get x by itself. So going through all the steps to get x by itself. I'm going to add x, add 4, add 4. And that leaves me with -7x is greater than 6. That's because these two cancel out. I'm going to divide by -7. And notice again, I divided by negative. So what am I going to need to do? Flip that sign. So x is less than -6/7. So the only difference between a linear equation and a linear inequality is you have to pay attention to the sign. Questions, comments, concerns? Are we feeling it? All right. Now let's do a little bit. So again, Your job is to isolate the variable and pay attention to your signs. So the first thing I'm going to do is what? Distributive property. I'm going to distribute to get rid of my parentheses. So when I distribute, you get a 2, you get a 2, we all get a 2. So we get -4 plus, now I don't know where that came from. You see nothing. -4 plus 6x is greater than or equal to 8 minus 2x plus 4. I'm going to clean up. That gives me 12 minus 2x. Our job again is to keep isolating the variable. Well, to get the variable isolated. Using what 8x is greater than 60. I just got lazy. Thank you. And divide by 8. And I'm left with x is greater than or equal to 2. How do we feel? I kind of need to backtrack because I forgot to go over with how to graph it on a line. I know it sounds pretty straightforward. I'm going to go back, but I forgot to go over it. So, graphing your solution. Here's your line, your number line. I'm going to just put 0 somewhere. I'll put 1 somewhere. And I'm going to put -1 somewhere. I'm sorry. And I'm going to say here's -6/7. And I know at -6/7, it's going to be an open circle. And it's less than, so I'm heading to the left. Now, on your homework, they do something weird. They do not do open circle. They actually put a parenthesis there. So on your homework, it'll be parenthesis and then an arrow to the left. If it asks you to pick a graph, because you don't actually draw the graph, it's multiple choice, and you just gotta select the one that fits the description. Okay. The next thing is, so this is graphing. Graphing our solution. It may ask you to write your solution in interval notation. So writing my solution in interval notation, I know that I'm going from -infinity up to -6/7, and they're both in parentheses. Because parentheses are always with infinity, and because it's not equal to, I utilize parentheses at 6/7. Sorry, I forgot to do that there. Okay. Are those added situations doable? Being able to graph it on a number line and write it in interval notation. Okay. So let's do this one. So my solution was x is greater than or equal to 2. So when I create my number line, I have 0, and I have a 2. At 2, I'm a closed circle, but for your homework, it's going to be a bracket, because closed circles and brackets are equivalent statements, right? And my arrow is going to be heading forever to the right, because it's greater than. Depending on the textbook is which one would be acceptable. Our textbook takes the top one. Other textbooks take the bottom one. Like the high school textbook is the bottom. Okay. Our interval notation, yes. Here. How did we go to 12? 8 and 4. Yes. This right here, this is implied negativity. Yeah, so this is implied negativity. When you're subtracting a positive, it's the same thing as adding a negative. So you would distribute it as a -2. Good questions, good questions. I like questions. I love questions, actually. I don't know why I keep writing the word solution like I'm going to remember to put it in that space. Who knows? All right, so graphically, when you're graphing two solutions, please tell me I put a graph. I did not. My sketch is about to be real horrible, y'all, but here we go. So graphically, when you're graphing these two solutions, we're going to go over it by hand, and then we're going to demonstrate it in the calculator for a prettier graph, okay? So by hand, you are graphing the left side and the right side as two separate linear equations. Make sense? So I'm going to draw the world's straightest lines for you. And my first graph is x plus 3. So I know that it's going to go through 3, which I'm going to put there. 2, 1, dun, 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 dun. And at 3, my slope is 1. So I'm going to rise 1, run 1. I'm going to fall 1, crawl 1. And I'm going to connect these dots. Fall, crawl, fall, crawl. Now pretend that these, again, are the straightest lines you're about to see in your life. And that I'm going through every point. I am concentrating so hard right now. Boom. Went through every point because I told you I did. Now I'm going to do the same thing for the next one. The next one is 2x. This time my slope is 2 and my y-intercept is at 0. So at this one, I'm going to go up 2 over 1. Up 2 over 1. I'm going to go from here down 2 over 1, down 2 over 1. We all understand how I'm graphing, right? Like using slope and y-intercept. Again, these are the straightest lines you've ever seen in your life. Boom, bam, thank you. Shh. We've already discussed, these are the straightest lines. So you're looking for at what point is the function x, the equation x plus 3 less than the equation 2x. So in order for it to be less than, I need to be beneath it. Does that make sense? So when does this graph, this one, fall below this one? And as you can see here, it's after this point, right? After this point is where I'm going to have less than values. When all the x's, after this point is where I'm going to have those less than values. And it'll just keep going and going and going. I'm not about to scribble. So we're going to now take a gander on El Calculadora. Here's my beauty. So I go to y equals, And in y equals, I'm going to put in x plus 3, x plus 3, and I'm going to put in 2x. And I'm going to graph, I'm going to show you what it looks like graphically. So I just want y'all to see, my graph is pretty darn close to that one. Pretty darn close, right? Yeah. Yeah, it's all there. So we're going to go back, and to make it inequalities, when we're saying something is less than or greater than, we're going to look at the table and see at what point do these values, the values of 2x, become greater than the values of x plus 3. That's what you're looking at. At what point does this take place? So I'm going to look at my table. Hope it's there. Guys, why won't it let me? Oh, it did. I was like, why won't it let me look at my table? So I'm looking at my table. At what point does y2 values become greater than y1 values? It's here, right? At 3, 6. So after 3, 6, that's when it becomes greater. So therefore, my answer would be at x is greater than or equal to 3 is when when this becomes a true statement. Do you all see where these points change direction? So y1 was bigger, then bam, after x equals 3, now y2 is bigger. Y2 is bigger. Oh my gosh, and y2 is bigger forever. Oh, nope, we didn't do that. Okay, so then my solution, let me get out of a highlighter, is when x is greater than or equal to 3. That's when this takes place. I didn't mean to shade all in the bottom, by the way, y'all. I don't know what I was thinking. I meant to just shade in here. I was tripping over here. Okay, so that's how you would do it graphically with a calculator. To me, it is so much faster to just take your little brain and subtract 2x, get negative 1x plus 3, subtract your 3, get negative 1x is less than or equal to negative 3, flip your sign. Okay? It is, to me, it is just faster and quicker to do it symbolically, but it is your choice if on the calculator portion or while doing your homework, you choose to check yourself graphically. Make sense? But you can't say I didn't show you graphically. Done, I showed you. All right, so here we have solve 2 minus 3x is greater than x minus 1 by using the x-intercept method. Then solve the inequality symbolically. So x-intercept method is just saying to find where do they intercept. And so this method is wanting you to solve it as if they're equal to each other. So 2 minus 3x equals x minus 1. And so you're going to solve it as if they're equal to each other. So I'm going to add 3x, add 3x, add 1, add 1. Cancels, I get 3 equals 4x, divide by 4, divide by 4. So I know that x equals 3, 4. This is where they intercept. So at x equals 3, 4 is where I'm going to intercept. Okay? So intercept method means that now you're going to take the value of the intercept and you're going to plug it into each one. So this was part 1 of it. Part 2 is I'm going to substitute it into each part of the function. So if I have 2 minus 3 times 3/4, and I have 3/4 minus 1, I'm going to have 2 minus 9/4, and that's going to give me negative 1/4, right? And then 3/4 minus 1 is negative 1/4. So you're checking yourself. So your intercept point, your point of intersection is at 3/4, comma, negative 1/4. So if it asks, here's your point of intersection. And you're going to choose a point that is either greater than or less than 3/4 and test it out. So you can choose a point that's greater than or less than 3/4. Okay? I would say if I always just use 1 or 0, because to me those are just easier and make sense. So if I test x equals 0, and I plug in x equals 0, I have 2 minus 3 times 0, and I have 0 minus 1. That's going to give me 2. That's going to give me negative 1. And I'm looking for when is it greater than? And if I test it at 0, it's going to be, it's greater than here, right? So therefore, the answer would be x is greater than when x is greater than 3/4. And why is it greater than 3/4? Because 0 is greater than 3/4. To me, this method is unnecessary, but I showed it to you in case you need to see a bunch of steps. I would say stick to solving it symbolically one way, but x-intercept method is identifying the x-intercept and testing points above or below the x-intercept and seeing where it falls. Again, not a fan of it, but I showed it to you. So, all right. Numerically just means to test this using a table. Your call. If you want to test it using a table, go for it. But that's what numerically is asking you for. This is asking you to use a table. Okay? So if you were to use a table here, I'm going to show it what it would look like on a calculator with the table. I don't want to draw a table out. I know that sounds lazy, but that's the truth. Uh-oh. I need to clear away my stuff. 712. So with the table, the thing is, if you're using the calculator, there's no need for you to simplify. You can literally write everything as it is. Because guess what, guys? The calculator was made to do math. Oh my God. So that's my y1, that's my 0. I'm going to go look at the table, and I'm looking for when is y1 less than y2. There's the graph. Now I want to look at the table, and I'm looking when is y1 less than y2, and y1 becomes less than y2 after 1. So when x is less than 1, that's when it becomes. Do we see that? So at 1, that's when they switch roles. After 1 is when they switch roles. Not at 1, with 1. So that's why we wouldn't say equal to 1. We would say less than, strictly greater than 1. Questions about looking at the table? Again, can you still just solve this symbolically? Yes, you can. You get your 8 minus 2x plus 1 minus 3x. Combine your like terms. You get 9 minus, what is it, 5x? Less than 0. And then you're going to subtract your 9, you get negative 5x is less than negative 9, divide by negative 5, divide by negative 5, and you get x is greater than 9/5, which equals 1 and 8/10. Okay, now the problem with numerically is that if you're looking at it table-wise, you're not going to see that exact value. So if they're giving you a table, they're wanting you to read it from that table. Okay, this probably wouldn't be one you'd probably get table-wise because it has a decimal value instead of an exact value. So be careful with the table, especially when you're only visualizing integers. All right, so compound inequalities. Yay, compound. What compound means is that you have to work not just 2 sides, but you have to work 3 sides, okay? Is now that instead of being a mama with 1 baby, you have a mama with 2 babies, and you gotta make sure you feed them both the same, okay? Oh no, that's never gonna happen again. No, never again. All right, so we have 4x minus 1 in the middle. And my job is to isolate the variable still. So if I have minus 1, I'm going to add 1. I'm going to add 1 to all sides. I'm going to feed all my children, okay, the same amount of food. So then I'm left with negative 4 is less than or equal to 4x, which is less than 12. Is my variable isolated? It is? No. So what's the last thing I'll need to do? I'm going to divide all sides by 4. And so I have negative 1 is less than or equal to x less than 3. So my compound solution would be this guy. How do you feel about compound? All right, so then if I was to graph this, here's my number line. At negative 1, it would be a bracket. I'll put 0 here. And then at 3, it would be a parenthesis. And the line would be in between. Do we understand why? Because at negative 1, I am included, but at positive 3, I am not included. Yay, nay. Do you see compound being doable? Anyone's like, I can't do compounds? Okay. Remember, closed mouths don't get fed. So if you don't tell me nothing, I'm going to keep trucking. All right, here's compound even with fraction. Doesn't change the process. Even though there's fraction involved, it does not change the process. You still have to isolate your variables. My job here is to isolate t. You can pre-make a plan of what you're going to do. So if I wanted to isolate t, I'm going to make my plan. First thing I'm going to do is multiply by 2. Then the second thing I'm going to do is subtract 3. And then the last thing I'm going to do is divide by negative 1, which is going to cause me to flip my sign. Okay, so pre-making your inverse operation plans. So I pre-made my inverse operation plan. And this is what I'm going to do to all 3 sides to get my answer to what I needed to be. And so I'm going to make sure I do it to each one. So 3/4, I'm going to multiply by 2. Then from that answer, I'm going to subtract 3 and then divide it all by negative 1. That's literally what you're doing to each side, right? So here I end up with 6/4 minus 3 divided by negative 1. And 6/4 minus 3 is going to give me negative 6/4. Is that right? Yeah. Divided by negative 1. So instead of a negative, it becomes a positive. So this side is now positive 6/4. Why am I writing it at 6/4 still? I don't know, y'all. But I'm going to keep it. And since I divide it, instead of being less than, it's now greater than. I'm going to do the same thing to the 1. So the 1, I'm multiplying by 2, subtracting 3, dividing by negative 1. That gives me 2 minus 3 divided by negative 1, which is negative 1 divided by negative 1, which is positive 1, right? And again, my inequality is going to flip. So now I have positive 1. Because my inequalities have flipped, this entire thing is written backwards. So I'm going to mirror it. So we have 1 X is greater than 1, but less than 3/2. And that would be my final answer. So here's another strategy for solving compound inequality. Make your plan to isolate the variable, apply the plan to both sides, simplify the compound. Questions, comments? Are we not asking questions because we understand? Are we not asking questions because we don't care? Or are we not asking questions because we feel defeated? Okay. All right, word problem. So in Denver on the 77th day, March 17th, the sun rose at 7 a.m. And on the 111th day, April 21st, the sun rose at 6 a.m. Use a linear function to estimate the days when the sun rose between 6:10 a.m. and 6:40 a.m. Do not consider days after April 21st. Okay, so we're going to first start off by making our table of our data, what was given to us. So from this information, we are given our independent and our dependent variables. Our independent variables are the days. Our dependent variable are the time the sun rises. Does that make sense? So on the 77th day, the sun rose at 7. On the 112th day, the sun rose at 6. Okay, and it wants us to find out when y is between 6:10 and 6:40. Now the thing is, when you're doing the linear equation, is it going to tell you minutes, or is it telling you in terms of a fraction of time? It's telling you in terms of fractions of time. So when I look at 6:10, this is 6 and 10/60. Does that make sense? Because it's 10 out of 60 minutes. And this is 6 and 40/60 because it's 40 out of 60 minutes. Do we see that? So this is actually 6 and 1/6. And this is 6 and 2/3. That's because I have to take it from real world and put it in terms of math. So I'm looking for when do my y values fall between 6 and 1/6 and 6 and 2/3. Questions or comments of how we came up with our interval for our range? Okay, cool. So the first thing I'm going to do, it says use a linear function. So creating a linear function. For a problem like this, because the purpose is not for you to create a linear function solely, this would be one that would be on your calculator part. So you could utilize the calculator to create your linear function. So using the calculator to make your linear function, I'm going to put in 77, 112. One of my favorite features about this calculator, unlike the Inspire, you have to have at least 3 points to create a graph, to create an equation, and you only need 2 on here for a linear. Okay, it's going to give you the decimal. If you hit math, enter. Oh, it didn't do it. Hold on. Right. Let's try to do it the short way. This is stat. Did I do it the wrong way? Hold on, I did it the wrong way. Let's try it again. I'm determined to make sure this works. No, what am I doing wrong? Fiddle fart. I don't know. I didn't do that. All right, anyways. So here are the values, and then Zane said, and what did you do for your settings? Oh, you're on the newer calculator. Yeah, that's why, Zane. I was like, I don't have that feature on here. That's an 84, right? Yeah, nah, homie. Not on a good on 83. I was like, I never knew that you could do that. But oh yeah, that's also never fails. So finding the slope, if you need a more exact, remember slope is just rise over run. So that's your 7 minus 6 minus 6 divided by your, does it really matter which one I write it? No, it doesn't. Is it 72? I was like, and then now this always works. I know that for a fact. There it is. So I know that my slope is negative 1/35. My b is 9 2/10. So I have my equation is y equals, I just had a brain fart, y'all. What did I say? Negative 1/35 and 9 2/10. Okay, so you now have what your y is. This is what's replacing this. So your problem that you're solving is 6 1/6 is less than negative 1/35 x plus 9 2/10, which is less than 6 2/3. And now it's just a compound that you're solving. So your plan here would be to subtract and multiply, right? Subtract, multiply, subtract, multiply. You would do that to both sides. Notice that I'm going to end up multiplying by a negative. So what's going to happen? What's going to happen to my signs when I multiply or divide by a negative? They flip. The signs are going to flip. So if I multiply by a negative, the signs are going to flip. So I'm going to go ahead and subtract 9 2/10 from both sides. In the calculator, when you're putting in a fraction on our classic calculators here, so for example, you need to put the entire thing in parentheses. So I would put 6 and means addition, 1/6 minus 9 2/10. Do we see that? When you're putting a fraction into these calculators, you are putting the whole thing, a mixed number, into the calculator. You're putting it in parentheses. And when you say the word and, that means you are adding. It's 6 and 1/6. Okay? If you want to make sure you're keeping the exact values, you hit math, fraction, and it's going to pull up. So my exact value is negative 91/3. Okay? A little trick is since these are so similar, I want to reuse what I wrote and just change the 1/6 to 2/3. So I'm going to hit second, enter, and it pulls what I did back down. And now I can type in 2 and 3. And it's going to tell me my other one is negative 38/15. So I have negative 91/30 and negative 38/15. Notice how I'm holding on to my fractions until the very end. So we have, I forgot that quick, it was still in my face. Negative 91/30 and what was it? Was it 38/15? Negative 38, yeah. And negative 38/15. And then my last step that we said we were going to need to do is multiply everything by negative 35 and flip the sign. So I'm multiplying everything by negative 35. I'm going to multiply u by negative 35. I'm going to multiply u by negative 35. And flip the signs. I'm going to go back to my calculator. So here, I have that one already in here. If I type multiply by negative 35, and I want it in fraction, so I'm going to hit math, enter, enter. And it says you have 266 divided by 3. That's one of them. And then I'm going to do negative 91 divided by 30 times negative 35. And again, I want it in fraction so I can maintain as much. And I get 637 divided by 6. So I have 266. I remember these numbers. 2663. 266, 3. Flip the sign. And I have 637, 6, 6. So my x value has to fall in between these number of days. And it told me not to go past the 112th day. So now I can take these values and figure out what are they really in real world. Because no one walks around and says, I'm on the 266th, 30th, 3rd day. Can't even say it. Couldn't even figure it out. Of the year. So this would be on the 160th day is 637. And then 266 divided by 3 would be 88th day. So we have 88, was it 0.6? And 2/3 day. And then the other one was the 103rd. Okay, thank you. My brain is. So somewhere, I wrote 30th. So somewhere between these 2 days, dang, I'm struggling. You're my assistant. Was it 106? All right, so 88 2/3, 106. And so when I look at the days, so the 77th day is March 17th. To get to the 88th and 2/3 day, it would be what? 11 additional days. And so I would find 11 additional days. That would put me at the 88th day, which would put me on March 28th. So plus 11 puts me at March 28th. And then also on the 106th day, was that right? So 106 days, I'm just going to go backwards 6 days. So I would just do April 21st minus 6, which we get April 15th. Uh-huh.
Okay.
Why not? Oh, yes. Okay, you guys just didn't get to do your practice problems. Are y'all okay not doing your practice problems, or I can give y'all time to do the practice ones, your independent practice? Yeah. Hey guys. Did I kick the people out of what's a face? No! It should have been. Well, Xavier, why the heck wouldn't you say something? No, I thought it was. No, Xavier, hold on. It's there. Guys, it's recording. Y'all are freaking me out.